5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff.
Hey everybody, I'm Zach, and if you haven't already guessed, my project's about rocket launches. Before we dive into my actual simulation itself, I kind of wanted to go over some of the aspects and things I had to learn about rocket launches in order to make this simulation, Here is the reference force diagram I used for my rocket. As you can see, this is from NASA, and my simulation doesn't fully follow this forces, so I did a straight up and down simulation. So there was no lift, but there was drag and thrust. Now let's go over the equations for each of these real quick. So the first of the three forces acting on my rocket in my simulation is the force of gravity, and that's using Gruton's gravitational equation, where you have a gravitational constant, two masses, and then the distance between them squared. The reason I used this equation was because as you get farther away from the surface in the rocket, your gravity actually decreases because you're getting farther from the Earth. The second of the three forces acting on my rocket is the thrust force, which is what propels the rocket forward. So this equation, which is the one I based mine off of for my project, is also from NASA. For mine, I simplified it down to just the mass flow rate multiplied by the velocity. In the case of my program, the velocity is the exhaust velocity, and the mass flow rate is the rate at which the rocket burns the fuel. The last force acting on my rocket is the drag force. Now, the drag force is equal to 1/2 times the density of the fluid that it's in times the velocity squared times the drag coefficient times the cross-sectional area. For my program, in order to simplify this, I just combined area and the 1/2 into the drag coefficient. So I got a final equation of the air density times the drag coefficient times the velocity squared equals the drag force. Now, because of my program, everything is changing. The air density is getting less as the rocket moves up. I had to account for that. Alright, so the part you've all been waiting for, my simulation itself. Before we jump right into the simulation, I just wanted to let you know that I modeled my rocket off of SpaceX's Falcon Heavy rocket. So these dry mass and fuel mass variables you see here are based off of that. But everything is adjustable inside the program, pretty much. In case you were curious, there's like 345 lines of code in this. Didn't take as long as I thought it would. Alright, let's jump right into it. So, when you first load in, you're going to see this beautiful rocket without wings because GlowScript is just not nice when it comes to making things easy sometimes. You'll have three different options. You have the Earth, the Moon, and Mars. I've adjusted the spaceship colors for visibility. There are some instructions here. Basically, those options, you can freeze it or reset it at any time. In order for fuel changes to take effect, you have to reset the simulation. There are some stats here to show you some things about the rocket while it's happening. The rocket mass is equal to the amount of fuel plus the dry mass of the rocket. And then there's some celestial body information. So it shows you the one you currently have selected, its mass and its radius. If you notice, I switched this to the moon. It changes. You can change the exhaust velocity, which adjusts how fast the exhaust is pushing out, which in turn of Newton's third law pushes the rocket up. You can change the total amount of fuel and the simulation speed. So if we just do a quick launch, let's bump this exhaust velocity up. We hit launch, the rocket's going to start going. There's no smoke, unfortunately, but what can we do? You'll see two graphs, altitude versus time and velocity versus time. This graph will flatten out once the rocket runs out of fuel. And you'll notice that gravity is getting less because this is the only force really acting on it at this point because it's getting further away from the Earth. You can actually, if you freeze reset, Let's bump up the speed a bit. You can actually watch the ground getting smaller, which is really cool. And it just gets really small really fast before it disappears. So what if we bump down the exhaust velocity to the default actually, which is about 2500. I really ramped it up there before. And then we try launching. So you're going to go up and up and up, and right now you're losing. You've already run out of your fuel, and you're starting to accelerate down. The altitude is dropping, and you're just going to crash into the ground. And when you hit the ground, the gravity is just going to be 9.8, and rocket mass, altitude is 0, velocity is 0. Yeah, and oh, you got like a nice arc curve because it comes crashing down right here. So yeah, pretty cool. And one thing you'll notice actually is if you switch this to the moon and we do another launch, you'll notice that you're going to escape the moon when you otherwise probably wouldn't have. I'm not sure exactly what escape velocity is on the moon, but you're going to get way far away before this ever catches up. So yeah, this is my project. I wish it could be a little bit prettier but GlowScript isn't all about looks apparently. So yeah, I hope you enjoyed.